Alright, Math, Chapter 8, Section 2, Applications of Venn Diagrams and Contingency Tables. Notice that when we have a single set, set A, inside our universal set U, there are two regions in the diagram. The region designated by A, which they're calling region 2, and everything outside of A, which is region 1. And the numbers in this diagram are arbitrary. They just pick them. That don't really have any significance except to count the number of regions. And when we have two sets inside of U, the universal set is divided into four regions. There we go. We have region 1, which is everything that's not in one of the two circles, A and B. Region 2, which would be the elements that are part of A, but not also a part of B. Region 3 would be the intersection of A and B, the elements that belong to both of them at the same time. And then region 4 would be the elements that belong to B, but not to A as well. And again, the numbering of these regions is completely arbitrary. Now, what you're going to do is you're going to draw a Venn diagram similar to the one we just saw. And you're going to shade the regions representing the given sets. Pause the recording, give this a try, and resume the recording to see how you did. Okay, first we have the complement of A, its intersection with B. So what we would do to figure this out is we would find the complement of A, which would basically be everything except regions 2 and 3. So we would be talking about regions 1 and 4, and then the intersection with B. B is 3 and 4. So the complement of A, which is 1 and 4, intersected with 3 and 4, gives us just region 4, so just that one part is shaded. For part B, we have the complement of A combined with, or in union with, the complement of B. So the complement of A would be 1 and 4, and the complement of B would be 1 and 2. And the union means put all these together, so that gives us 1, 2, and 4. Venn diagrams drawn with 3 sets will divide the universal set into 8 regions that can be numbered. So we're going to try this out. There's an example there. You can see all 8 regions. One of them is where all 3 circles meet. You're going to shade the complement of A in union with B, the intersection of B and the complement of C in a Venn diagram. Now, let me suggest that just like with regular math, you start with the parentheses first and get that part nailed down, and then find the union of that with the complement of A. Pause the recording to give this a try and resume the recording to see how you did. Okay, here's our answer. First, let's look at the parentheses. B would be regions 3, 4, 7, and 8. And the complement of C would be 1, 2, 3, and 8. So the union of 1, 2, 3, 8, and 3, 8, 4, and 7 would be 3 and 8. And then we're going to combine that with the complement of A, which is going to be 8, 7, 6, and 1. So that's why we have regions 3, 8, 7, 6, and 1 all shaded in. Okay, here's a practical application of Venn diagrams. We have a market researcher collecting data, and he's collecting data on cable television and high-speed internet. He finds that 81 of the 100 households that he researched have cable television, 65 have high-speed internet, and 56 have both. And he wants to know how many households do not have high-speed internet, how many have neither cable nor high-speed internet, and how many have cable but not high-speed internet. What you're going to do is you're going to create a Venn diagram with 2 circles. One will represent those with cable television, and one will represent those with high-speed internet. Why don't you pause the recording and give this a try, see how you do, and resume the recording to check your answer. So we're going to construct a Venn diagram, and what we're going to do is we're going to put 56 in the intersection of the cable television and high-speed internet because 56 have both. Now, 81 have cable television. We're going to take out the 56 that we put in the intersection, and that leaves us with 25, and those are the ones that have cable but not high-speed internet. And then what we're going to do is we're going to take 65 minus 56, which gives us 9, and that's 9 households that have high-speed internet but not cable. And then you know that there were 100 people surveyed, so you could take those out and find out that 10 have neither. Here are the diagrams. Notice how we first put the 56 in the center, and then we figured out each side by subtracting 56 from those figures. And we knew that they all had to add up to 100. And then we were able to answer the question. Okay, let's try this one. You have a group of 60 first-year business students, and they were surveyed with the following result. 19 read Business Week, 18 the Wall Street Journal, 50 read Fortune. 13 read Business Week and the Journal, 11 read the Journal and Fortune, 13 read Business Week and Fortune, and 9 read all three. So, how many students read none of them? How many read only Fortune? And how many read Business Week and the Journal but not Fortune? You're going to create a Venn diagram, this time with 3 circles, and they should all overlap in the middle. Now, before you get started on this, let me suggest that you start with the 9, place that first, and then you can start to place the others. Place the intersections first. Okay, so pause this recording, give it a try, and resume to check your answer. Okay, so we start by putting the intersections in. The 9 that read all 3. There were 13 that read Business Week and Fortune. Now, 9 of those would be the ones who read all 3, so there'd be 4 left that read just those 2. Okay, then that lets us put in the ones who read Business Week and Journal and Fortune in the Journal. And again, we'll take the 9 out of those because that represents the people that read all 3. And then we can finally start putting in the numbers. So Business Week, we only have 2 that read it exclusively. And then fill in Fortune and Journal. We've got those there. And finally, we find that 1 of those surveyed don't read any of them. Okay, one more example. Dr. Mark McCloney saw 100 patients exhibiting flu symptoms such as fevers, chills, and headache. He reported the following information on patients exhibiting symptoms. Of the 100, 74 reported a fever, 72 chills, 67 headache, and then you have the information on the intersections of those. 55 both fever and chills, 47 fever and headache, 49 chills and headache, 35 all 3. 3 thought they had the flu, but did not report any of them. Create a Venn diagram to represent the data, and it should show the number of people in each region. Remember, this should total 100 patients. Pause the recording, give this a try, and resume the recording to see how you did. Okay, here's where all the numbers should fit in. Compare that to what you have. Remember, you start in the middle with the intersection of all 3, and then you move out to where the 2 intersect, and you have to take the 35 out of those, and then you move out to the individual symptoms, removing what's already in the circle, and they told us that 3 didn't have any of the symptoms. Now we're going to talk about the addition rule for counting. The symbol in parentheses A is used to represent the number of elements in A. So if A is WXYZ, then the number of elements in A is 4. Now, to determine the number of elements in the union of 2 sets, we're going to use the following rule. The number of elements in A in union with B is the number of elements in A plus the number of elements in B minus the number of elements in the intersection of A and B. Now, why we do this is that if you don't subtract out the intersection, you're actually counting those twice because they get counted as a part of set A and as a part of set B. So you need to take them out so they're only accounted for one time. Okay, let's try this. We got a group of 10 students that meets to plan a school function. All are majoring in accounting or economics or both. 5 of the students are economics and 7 are in accounting. How many major in both? So what you're going to look for here is actually the intersection. So you're going to use the same formula, it's just that what you're looking for is the intersection. Pause the recording, give it a try, and resume the recording to see how you did. Okay, so A is going to be the set of economics majors, B the set of accounting majors. So the number of members of A is 5, the number of members of B is 7, and the union of the two is 10. So we're just going to put those numbers into our formula. 10 equals 5 plus 7 minus the intersection, and that gives us 2. So 2 of them are majoring in both subjects. All right, let's try this. By the way, this is called a contingency table, and it's really just these things. It's just an organized table that gives you information. The following contingency table gives the number in thousands of males denoted with an M and females denoted with F who are working full-time, which is denoted by A, working part-time denoted by B, or not working denoted by C in the year 2010. Okay, so we're going to find the number of people in the given sets. We're going to find the number of full-time workers. We're going to find the intersection of women who are full-time workers. We're going to find the intersection of men who, or the union of men and those that did not work. And then we're going to find the union of those who work part-time or not at all. The union of that intersected with the number of females. All right, pause the recording, give this a go, and resume to check your answer. Okay, set A contains male and females who worked full-time. So there were 56,414 males, 42,834 females, which leads us to 99,248 people who worked full-time in 2010. The intersection of the people who are female and work full-time, you can actually just read that right out of the box. That's one nice thing about contingency tables. Where those two categories meet, you find 42,834 females who worked full-time. The set of men combined with those who did not work, we're going to use the addition rule for counting. So the union of that, it's going to be the number of those in the category of men plus the number of those in the category of not working. And we're going to subtract the intersection. So you find the total of all the men. You find the total of all those not working. So the total of men is 116,802 males. The total number of those not working was 86,776. And then we're going to subtract the intersection, which is where the row and column meet, the row for men and the column for not working meet. And that was 35,729,000. And then we just put those numbers into our formula, and we find that that equals 167,849 people. And finally, we have the union of B and C along with the intersection of F. All right, to begin with, the set B union C contains all those who work part-time or not at all. So what we're going to do is we're going to take, and of those we only care about the females. So we're going to take the females who work part-time and the females who didn't work, and that gives us 80,279. So this is extra practice. So as you go through this, pause the recording, give these a try, and resume the recording to check your answer.